Diesel down 18%. Reported carbon unchanged. That's not a mistake in the maths. It's a mistake in the boundary. A site team cut fuel, evidenced it, and still couldn't claim the reduction. If you've ever had a carbon claim challenged and couldn't work out why, this is usually where it went.
Here's what happened. The fuel savings were real. You could see them on the Bowser dockets. But by the time the numbers reached the report, they'd vanished. Because most site carbon plans measure activity. They don't check which emissions those activities are actually assigned to. In this video, I'll take you through 3 of the most common reduction measures on an active site. One of them, used the way most teams use it, can actually raise your reported figure. By the end, you'll know which reductions survive an audit and which ones an assessor rejects on site.
Start with the boundary. Site carbon lives in something called Module A5. A module here is just a labeled stage in an asset's life. The standards cut the whole life of a building into numbered stages so that everyone counts the same things in the same place. A5 is the construction process stage. It covers what happens while you're building, not the materials themselves and not the finished asset in use. Under the RICS Whole Life Carbon Assessment, 2nd edition, A5 splits 4 ways. A5.1, pre-construction demolition, A5.2, construction activities, plant fuel, gensets, temporary works, site accommodation, A5.3, waste and waste management, and A5.4, worker transport. Note that last one. A5.4 is optional under RICS. Check whether your client requires it, because if they do and you haven't counted it, that's a hole in your inventory.
Now the exclusions, because that's where the errors are. 3 things get wrongly booked to A5. First, not A1 to A3. The carbon in your cement, your steel, your rebar, that's product stage. It was fixed before your delivery even started. Second, not B6, the completed asset's operational energy, the lights and the heating and the running of the building, different stage, different owner. Third, and this is the common one, not A4. Transporting materials to your gate is A4. Moving them around once they're inside the boundary is A5. Get that wrong, and you don't shift A5 by a few percent. You shift it by a factor.
So what actually counts as a reduction you can claim? 5 tests. 1. Boundary stable, measured inside the same inventory boundary as your baseline year. 2. Attributable. The emission source is under your operational or financial control. 3. Not a transfer. The emission left your inventory, not the atmosphere. And that third one is where audits fail. If you subcontract your plant fleet, those emissions move from Scope 1, the fuel you burn yourself, to Scope 3, which is someone else's. Same diesel, same atmosphere, different column. 4. Evidenced. Fuel dockets, telematics engine hours, metered kilowatt hours, not a modeled estimate. And 5. Normalized, which means expressed per unit of output rather than as a raw annual total.
Which brings us to the baseline, your reference year, the thing every reduction gets measured against. A fixed absolute baseline breaks the moment your scope changes, and on a live project, it always changes. Recalculation triggers are structural change, boundary change, or a discovered error above your significance threshold. Here's a real one. Between DEFRA's 2025 and 2026 factors, the UK grid factor fell from 0.177 to 0.131 kilograms of CO2 equivalent per kilowatt hour. A 26% drop. Same consumption, lower reported emissions. A reduction you did not cause and cannot claim. Intensity baselines survive that. Per cubic meter placed, per square meter completed. Set the unit before mobilization.
because retrofitting one is an audit finding.
Everything we've just talked about, it happens here. On most civil sites, plant and generator fuel is the largest single line in A5.2. So how do you actually cut it? In order. PAS 2080, Clause 6.1.4, sets out a carbon reduction hierarchy, 3 stages applied in sequence. Avoid. Delete the activity. Cut double handling, remove a temporary work sequence, or don't build the thing at all. Switch. Change the material or the energy source. Ground granulated blast furnace slag, GGBS, in place of cement. Recycled aggregate, HVO, a renewable diesel substitute. Grid or hybrid power. Then, improve. Same output, less input. Right sizing, idle control, load matching, waste reduction. Most teams start at switch because switch is procurable. You can buy it on a purchase order. But switch applied before avoid just buys expensive low-carbon fuel to run hours you never needed.
Lever 1. Plant and fuel. Usually the single biggest line on site. Your anchor number is gas oil, red diesel, at 2.75541 kilograms of CO2 equivalent per liter. That's pure fossil, no biofuel blend. Road diesel is a different number, 2.58354. Different fuel, different factor. Don't use one for both. Most site plant runs gas oil, most of your deliveries run road diesel. On idling, Komatsu reported 38% average idle across around 75,000 machines. Volvo Construction Equipment has cited 28 to 30% on large fleets. Telematics, the onboard system that logs engine hours, lets you set an idle shutdown at 3 to 5 minutes. That cuts fuel with zero capital spend. And HVO cuts life cycle emissions by up to 90%, but the accounting on it is not what you'd expect. Hold that thought.
Lever 2. Temporary power. And this is the one I promised you. Diesel gensets on site commonly run at 20 to 40% load, well below their efficient operating range. Load factor matters here. A generator running at a quarter of its capacity burns far more fuel for every unit of electricity it delivers. So, switch to grid power then? That depends entirely on the grid. Published Saudi grid factors range from 0.506 to 0.721 kilograms per kilowatt hour. Same grid, 4 different published sources. Pick the high figure, and grid power looks worse than a well-loaded genset. Pick the low one, and it looks better. So fix the factor and its source in writing before you model the switch, not after someone challenges it. And often, the real answer is neither. A load-managed hybrid battery unit that cuts genset run hours outright.
Lever 3. Movement, materials, and waste. 4 measures that cut A5.2 and A5.3 together. Cut fill balance, matching what you excavate to what you need as fill, so the material stays on site. Every cubic meter you export is a load out and a load back. Consolidated deliveries. Reduce A4 for your client and A5.2 for you at the same time. Wastage rate control. And remember, A5.3 counts the embodied carbon of material you ordered and then binned. Embodied carbon meaning the emissions already locked into that material before it ever reached you. And concrete over-ordering. Highest carbon material on most sites and the most routinely oversupplied. Wasted concrete doesn't just waste concrete, it wastes cement carbon at the full A1 to A3 factor.
Here's how that plays out on a real package. 1. Infrastructure contract. 2. Reduction claims. Claim 1. A fleet idle control program. 11% fuel reduction, evidenced by telematics engine hour logs. Claim 2. The earth-moving fleet transferred to a specialist subcontractor. 24% reduction in reported Scope 1. Claim 1 was accepted. Claim 2 was rejected.
The emissions moved to Scope 3. They did not move out of the atmosphere. Net reported reduction before review, 35%. Net verified reduction, 11. And the second claim failed the normalization test as well. Earthworks volume had risen 9% over the same period.
5 ways a real reduction disappears. 1. Subcontracting the fleet. We've covered that one. Scope 1 becomes Scope 3. 2. And this is the one that catches almost everybody. The HVO biogenic split. Switch to HVO, and it looks like a 100% cut to your Scope 1 mobile combustion. It isn't. Under DEFRA 2026, HVO still carries a Scope 1 factor of 0.03558 kilograms per liter, trace methane and nitrous oxide. And the biogenic CO2, the carbon that came out of the plant material in the first place, gets reported separately, outside the scopes altogether. So it is not zero, and your inventory should not say it is. 3. Unnormalized comparison. Output grew, intensity improved, absolute emissions rose. 4. Market instruments booked as reductions. Certificates change your reporting. They don't change what burns on site. And 5. Offsets booked before the hierarchy. Reported as a reduction, rejected under assurance.
And some good measures backfire. Electrifying plant on a fossil-heavy grid can move emissions without reducing them. Exactly the same problem we hit with temporary power. Consolidation centers cut movements on your site, but they add a leg to the journey. Model the whole chain, not just the part at your gate. And cement replacement, GGBS or fly ash, reduces A1 to A3 substantially, but it slows early strength gain, longer cure, longer striking times, and if that extends your program, it extends your site energy with it. Almost nobody models that consequence. So every A5 measure with a program impact needs a schedule check before you claim it.
So what does verification actually ask for? Assurance, an independent check of your numbers, works from evidence, not from intent. Fuel and plant, a fuel docket or supplier record, plus the plant ID, plus the reporting period. Electricity, a meter reading or utility invoice, the meter boundary, and the period. Waste, a transfer note or weighbridge record, the waste stream, and the destination. Material and delivery, a delivery ticket or quantity record with product, source, and date. And for the reduction claim itself, your baseline, the changed activity data, the factor and method, and the calculation trail. One more thing. Reconcile fuel purchased against fuel consumed every month. An unexplained variance above roughly 5% is where most assurance findings start.
So, Monday morning, 5 things. Set your normalization unit now, per cubic meter placed, per square meter built, per ton moved. Pull 1 month of telematics idle hours. That number is your first target, and acting on it costs nothing. Get your actual grid emission factor and its source before anybody proposes a temporary connection. Check whether any reduction sitting in your current report is really a subcontracting transfer. And start at the top of the hierarchy. Offsets are the residual. They're not the plan. If you only do one of those 5, do the first one. Every other claim you make depends on it.
If that was useful, subscribe. Site-based environmental and sustainability training every week. Next in this playlist, we go into verification and assurance of construction stage carbon claims in detail. And in the comments, tell me the one reduction claim your team can't currently evidence. I read them, and they shape what gets made next.